What is the role of energy storage in the electricity grid?
In the electricity grid, there is very limited capacity to actually store electricity once it's been generated. So it really needs to be consumed at almost the same moment as it's been generated. If we want to increase the energy storage capacity of the electricity grid, then we need to deploy energy storage systems to act as the electricity warehouses, if you like, of the grid.
So perhaps you could explain how you do that.
There are actually several ways to do this, each with its own pros and cons, or sweet spot, in terms of application. One that has really come to maturity over the last decade or so has been battery energy storage systems. Now these might even use the same technology that you would find in your mobile phone or your laptop, just on a much larger scale. The vast majority, though, of the existing energy storage capacity on the grid, which has been around for over a century now, is pumped hydro storage. With that, excess electricity in times of low demand is used to pump water uphill into a reservoir. Then, when demand is high again, it's allowed to flow downhill, and it releases its stored potential energy by turning a turbine and a generator to put power back into the grid.
What will it be used for?
Well, if we look at what pumped hydro energy storage systems have traditionally been used for, it's exactly this analogy of producing metals and other raw materials at a stable rate, then managing the mismatch between supply and demand with warehouses. Today's fleet of pumped hydro energy storage systems was deployed to allow large thermal power stations, such as coal and nuclear, to generate electricity at a stable rate, where they also see the best operational efficiency. The pumped hydro energy storage facilities then really act as the electricity warehouses for these power stations.
But now comes renewable energy.
Yes, in recent years, the rise of renewable energy sources like wind and solar has created a new challenge for the grid. This is partly because the rate of power generation from them is dictated largely by the weather and other factors which are outside of our control, and of course are very difficult to forecast accurately. This kind of power generation might also be installed anywhere in the grid and in really any size. These might range from large wind parks far offshore to very small solar installations on the rooftops of residential houses. What this means for energy storage systems, if we want to continue to use them to manage the mismatch between generation and consumption, is that they also have to be installed anywhere in the grid, in whichever size they are needed and whichever reaction speed is needed.
How much power can be stored?
We don't really have a technical limitation there. Already today we have on the grid energy storage systems ranging from tens of kilowatts in power to hundreds of megawatts. They can also supply that power for as long as needed, whether it's seconds, minutes, or up to several hours. What's really important with all of these different energy storage technologies is both to understand them and understand fully how they interact with the electricity grid.
Thank you, Steve, for sharing your thoughts with us.
Thank you, Mark.